Welcome to another session on morphological image processing. In this video, I will be discussing about some frequently appearing questions in the exam question paper. Those are the boundary extraction, region filling, and convex hull. These are some of the morphological algorithms that are actually not mentioned in the syllabus but appear in the question paper. Boundary extraction is done by taking the set and performing the erosion of that set and subtracting that result from the original set. So this is the boundary extraction. Let us understand the boundary extraction from this set A. So A is a set and we have to find the boundary of this set. So B is the structuring element. So this dot indicates the origin, and this kind of a structuring element is called the 8 connected. Why is it called 8 connected? You can, from this origin, you can traverse in 8 different directions. That is up, down, left, right, up, left, up, right, down, left, and down, right. Those are the 8 different directions. So therefore this is called as an 8 connected structuring element. We are going to perform the erosion of set A by this structuring element and we obtain a result like this. Therefore the boundary can be obtained by subtracting this result from the original set. So therefore we get the boundary of the set A. This is another example of boundary extraction. That is the definition of hole. So foreground pixels are the pixels that we are interested in, that is the pixels of the object, and the background pixels are the region or the pixels behind the object of interest. And hole is created by the connected border of foreground pixels. How we perform hole filling is, first we identify the number of points to be filled, and for each iteration we are going to perform the dilation operation and keep filling the holes and identify the region to be filled. And we stop the iteration at this stage, that is when we have reached almost the last point. Let us understand hole filling from this example. So this is the set A with the hole here, and this is a complement of the set, and this is a structuring element B. This is 4 connected because from here you can move only in 4 direction, that is from the origin. In the first step we identify the point. So we identify this point here and that we call it as the 0th iteration. In the next iteration we identify the next 2 points because you can move in only any 4 directions, and there are no there are no hole points here. These are the hole points, so we fill these 2. Next, in the next iteration we are going to fill the next hole that is connected to that. In the third iteration we go just 1 more point, and in the 4th we go the next, and in the 5th 1 more, and in the 6th we have 2 more points, and in the 7th we have this point, and in the 8th iteration we have all the points. So therefore you can observe all the points are identified, and in the last step we are going to add this set whatever we obtained in the previous with the original set A to get the final result that is the whole filled set A. Next is the convex hull. Here what we do is we find a set of matches for the structuring element during different iterations and stop the iterations when the condition here is satisfied. So like this we do the template matching for different structuring elements. So here I indicates the different structuring elements and K indicates the different iterations. Let us understand from the example. And finally what we do here is we add up all this to find the convex hull of, let us say, a set A. Let us consider this example to find the convex hull for this set A. The structuring element what we are going to use here is B1, which is a structure like this. This don't care, these are all the don't care conditions, and these is the matching, and this is a empty place. So where we can observe this pattern is, you can see in this region here, these are the three shaded and one empty place. Similarly, these are the three shaded and this empty place. Of course this is a shaded, so since in the structuring element it's a don't care, so you can take this. So all these three are the points that are the set of matches for the particular structuring element. So in the first iteration we are going to identify those points. Similarly these points. So this is the end of the first iteration. In the second iteration we are going to find another set of sets, and that is the end of second iteration. And in the third, those are the set of points in the third iteration, and those are the set of points in the fourth iteration. So here this is for the first structuring element. We started with the 0th iteration and stopped at the 4th iteration. It cannot be, no more matches could be found at this, after this stage. So therefore this is one set of result we've got for this particular structuring element. Next we will consider the second type of structuring element for the same set A. So this is the second set of structuring element B2, having the shaded pixels here, and since it is a starting step, so we are indicating it as 0, and since it's for the second structuring element, we put a 2 here, and it is the same set A we have used it. For this, let us see how many iterations it takes to find how many matches. So here we find only one match, and at the end of the first, and so in the second, so it is these two matches. So we are identifying where this particular match is here. So you can see that these are the three, and this is the don't care, this is the don't care, and here is the empty. So therefore this region is identified. Similarly these three, and this is don't care and this is don't care, so this region is identified. So this is the template matching for this particular structuring element, and there are no more such matches, so therefore the iteration stops here. Next we consider the third type of structuring element, and this is the result obtained for the third type of structuring element, that is, these are the matching sets points filled in A, and similarly for the fourth type we have this one point alone. If you observe the structuring elements, they're all shifted by 90 degrees between one structuring element to another. So the final result would be a set like this. Now this is what we call the convex hull of A. This is the set A, and this is called the convex hull of set A, represented by C of A. The same convex hull here is shown by different shades, different shading regions, to identify which are the sets, matching sets obtained for that particular structuring element. So this is convex hull. So with this we wind up the topic on morphological image processing. Thank you. The next video I will be taking up on segmentation.